Hello students, as you already know by this point, I am not at school today. I am sick and I have a fever and I feel well enough to come into school, but I don't think that would be a very good idea since I would probably get all of you little children sick in the process and we don't want to be spreading diseases around our school. So I decided to stay home today, but don't worry, even though I am staying home, geometry still continues on. So a couple of things that we need to go over first. And the first thing is this. You'll see on your homework sheet, I just pulled it up here, that due today was the worksheet that you did last night that you should have done yesterday while I was gone. I didn't get any emails on that, so I'm guessing that that went well for everyone. And then it says here that you are doing another worksheet tonight. Well, I'm not at school to be able to make copies of that worksheet for you. So you will not get that worksheet for tonight. In fact, you will be doing some book work, and I will list the homework assignment that is going to be in the book at the end of this video, so you can stay in tune for that. So you will have some book work. It won't be long. It'll be pretty short, but you will have some book work that you will have to do for your homework tonight. So just make sure you stay tuned to the end of this video. That being said, let's jump right into it so I don't take up too much of your time. The way today is going to work is just like yesterday. I'm going to go through the lesson. You will watch it. As you watch it, you should take notes. And then as you take notes, you can use your notes to go home and do the homework. I hope this worked well for you. I didn't get any complaints. I didn't get any feedback. So I'm going to assume that everything went well. And then I can continue it again just like we did yesterday. But if you have any feedback, please email me. I hope everything went well, and we'll get right into it. A couple things of note. I did not know I was going to be gone today, so unlike yesterday, I did not print these notes off for you. So you need to be taking notes on your own. And whenever we go to a new slide, I will prompt you, and all you need to do is just pause the video, write down everything you see on that slide in your notes, and then as we go through, you can add to those notes. So I will tell you whenever we go to a new slide, but you can pause the video and look along, or you could just pull up these notes on Haiku and add to your Haiku notes there, taking the notes on your Chromebook through Notable, or just having your notes on Haiku to refer to be able to write everything down. However you want to do it, you need to write this stuff down in some form or fashion. Okay? So with that being said, let's go ahead and get started. I think it's clear to see that this is familiar to you. These are going to be the same exact rules that we went over yesterday, but yesterday we were talking about proofs dealing with segment congruence. Today we're talking about properties of angle congruence. So let's just refresh really quick all of the properties that we've learned so far, and I'm going to type them down here. So far we have learned properties of algebra. That is what allows us to do mathematical operation. The rules and reasons why certain mathematical operations work, and other reasons why maybe we can or can't do some things. So that's my phone going off in the background. So the second thing we learned yesterday was properties of segment congruence. And then today what we are learning is obviously properties of angle congruence. These are all properties, these are all reasons that we can use in our proof. They're going to help us solve proofs. So you can write this down, you can write each of these down, you can pause the video, take a second to write these down. But these are the exact same rules as yesterday with segment congruence, just now dealing with angles. So make sure you get those down, and we're going to move on to the next slide. So moving on. Okay, at this point in the video, you should pause the video and make sure you have all of this down, or have this pulled up on Haiku and copy all of it down. But before we get started, I want you to have all of this, every single part of this proof to this point in your notes. So pause the video and take a second to do that. Okay, now that you have this all down in your notes, let's begin to go through it. Remember, anytime we should start a proof, we need to take a big step back and look at what are we given and what are we trying to prove. Well, here in this proof, we are given that angle 1 and angle 2 are complements. Well, what does that mean? Here is angle 1. Here is angle 2. Those two angles are complements. That means when I add them together, they equal 90, and that'll come into play in a second. What we are also given is that angle 3 and angle 4 are complements, which means that when we add those two together, their measures equal 90. We're also given that these two angles, angle 2 and angle 4, are congruent. So we can add a little arc mark here. And what that means, once again, is that 2 and 4, those two angles are congruent. And what we're trying to prove is that angle 1 and angle 3 are congruent to each other. So I want you to take a step back, pause the video for a second, look through the proof that you now have in your notes, and kind of see what you think it's going to take to prove this in the end, to prove that angle 1 is congruent to angle 3. You may kind of see the path ahead, you may not, that's okay, but wherever you are, I want you to kind of just read through the proof and get an idea of kind of where we're going. So pause the video and take a second to do that. Okay, now that you've taken a second to look through the proof, let's start going. Obviously, number 1 is exactly what we are given, so the reason for that is going to be that this information was all given to us. So there is that. Now, the number 2 is obviously blank, but we're given that the reason is the definition of complementary angles. So that is what we have used. We've used the definition of complementary angles to come up with some statement. Take a second, pause the video, and think about what that statement might be. What might number 2 be? In other words, what might given that angle 1 and angle 2 are complements, what could we deduce from that? That's reason would be the definition of complementary angles. And here's the hint. We may have already mentioned it. Pause the video, take a second, and think about it. Okay, so here we go. Angle 1 and 2 are complements. If we're using the definition of complementary angles, that means we're just going to rewrite this statement in mathematical form. So we are going to write, and let's see if I can write this, the measure of angle 1 plus the measure of angle 2 equals 90. And we know that that is true because that's the definition of complementary angles. The fact that 1 and 2 are complements means the measure of angle 1 plus the measure of angle 2 equals 90 by the definition of complementary angles. But that's not all. We can also say that the same thing is true for angles 3 and angles 4. So both of these are going to be our statement for number 2. Now, once again, the statement for number 3 is blank, but we know the reason is substitution. So clearly we're going to be substituting something to get our next statement. So I want you to pause the video, take a second, and look at where we might be going. Now that you've taken a second to think about it, I hope that you're building up some of these proof writing skills. Here's what I mean. We can't just pull this substitution out of nowhere. Remember, this only comes from the excuse me, the fact that of what we have already introduced into our proof. So remember, we introduced in number 1 that angle 1 and 2 are complements, but we already used that idea to come up with number 2. Same thing with angle 3 and angle 4 being complements. So these we've already used in our proof. Those are no good to us anymore because we've already used them. So what we haven't used is that angle 2 is congruent to angle 4. And then this statement number 2. What could we substitute in this statement for each other? Well, I think it's clear to see that what we could substitute is we could say that, well, 90 equals 90, but that wouldn't really help us. But because both of these angles equal 90, or both of these sums of these angles, measure 1 plus measure of angle 2 and measure of angle 3 plus measure of angle 4, because they both equal 90, then that means that we can set them equal to each other. So here's what I mean. Number 3 would be, let's see if I can write all of this neatly, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 4. And the reason that we know that's true is because of substitution. Because both of these sums equal 90. So since they both equal 90, we can substitute in for 90 here. What we really did is we took this 90 and we just turned it into measure of angle 3 plus measure of angle 4 in this statement by substitution. So now let's keep going. So now we have the statement measure of 2 equals measure of angle 2 equals measure of angle 4. Well, where does that come from? That comes from this statement here that says angle 2 is congruent to angle 4. And we've already talked about this yesterday, just like segment congruence, when we see angle 2 is congruent to angle 4, and then we see the exact same statement but written when it is referring to their values. In other words, we have an equal sign here. Oops. We have an equal sign here, and we have measure, meaning value, then the reason we can do that is that is what the definition, my mouse has lost its touch. That's the definition of congruence. Okay, that's a bad E. There we go, that's a little better. Definition of congruence, it's a bad C. Let me fix that. There you go. So now we've used these, we've used that, we've used this. Now, some combination of numbers 3 and 4 is going to give us this statement. Well, I think it's clear to see that this statement is exactly the same as this statement here, except the only thing that's changed is where it says measure of angle 4 here in this statement. Here in this statement it says measure of angle 2. Where did that come from? Well, clearly it came from number 4. The fact that measure of angle 2 equals measure of angle 4. That means that we can substitute it in for each other. Wherever I see 1, I can substitute the other. Wherever I see measure of angle 4, I can substitute in the measure of angle 2 and vice versa. So that reason is substitution. The measure of angle 2 equals the measure of angle 2. That one should be easy. That is the reflexive member property of angle congruence, but you can just say reflexive property. And if you had forgotten, you could just go back to our last slide. Oh, yep, that's the reflexive property. Measure of angle 2 equals the measure of angle 2. So now what we're using is this reflexive property, number 6 there, to come up with some combination of number 6 and number 5 and number 6 is getting us to number 3. Well, how did we get this statement? We got this statement because since the measure of angle 2 equals the measure of angle 2, if I subtract a measure of angle 2 from each side here, if I subtract a measure of angle 2, because the measure of angle 2 equals the measure of angle 2, if I subtract, then this statement will still be equal, but what will happen to the measure of angle 2? They will just disappear, and this whole statement in number 5 will become this statement in number 7. And how did we get there? Well, we subtracted. Subtraction, we used the subtraction property of algebra. And then I think it's clear to see that, okay, what are we trying to prove again? Let's remind ourselves. We're trying to prove that the measure of angle 3 is congruent to angle 1. And if we can say that their measures are equal, then we can say that those two angles are then equal. And that, we can say that, I hope you can fill this in on your own at this point, by the definition of congruence. And there you have it. There is our whole proof. That was quite long, but that's okay. I think this is a pretty good proof. It's kind of a tough one. There may have been a couple places where you're saying, I have no idea where you got that, and that's okay. That is totally okay. What I want you to see here, though, is that what we have proved is that this is true for every case of this. Anytime we have two sets of angles that each are complements to each other, and one set of the angles is congruent to each other, that means the other set of angles must also be congruent to each other. We're not just proving this one case, remember. Anytime we prove something, we are proving that that is true in all cases. In all cases. Notice, we didn't use a single specific measure in here except for 90. So this isn't dealing with specific angles that have one angle measure and another angle measure. This is just saying anytime any two angles are complements, and then we have another set of angles that are complements, but two of the angles equal each other, that means the other two must equal each other as well. And there you have it. So at this point, what I want you to do really quickly is pause the video, and I want you to go ahead and pull out your theorem and postulate sheets. So pause the video and do that real quick. Okay, and what you'll see is that what we actually proved as we're moving on is we actually proved theorem 2.5. You just proved the congruent complements theorem. The congruent complements theorem says this: if two angles are complementary to the same angle or to congruent angles, then the two angles are congruent. Once again, that's kind of hard to decipher exactly what it's saying right away, so we have this picture to show us. If two angles are complementary, meaning this. If we have two angles, A and B, where when I add them together, each of their measures, they equal 90. And they're complementary to the same angle. That means that when I add A and B, that equals 90. And then when I add B to C, that also equals 90. Then the two angles are congruent. So our two angles here would be angle A and angle C. Both of these angles, when I add them together with B, I get 90. So when I, let me draw it this way. So when I add angle B to angle C, I get 90. And when I add angle A to equals angle C, I get 90. That's an equal sign. That means that angle A and angle C have to be congruent. There's no way around it. That if I add A to B and C to B, and in both cases I get 90. That means that angle A and angle C must be congruent. Wow, I'm failing this time. Must be congruent. And the same is true of supplements, and I think that shouldn't be too easy to see. That if we have two angles, A and B, that when I add A and B together, A plus B, they are supplementary. That means when I add them together, they equal 180. And then I have another set of angles that are supplementary, meaning B plus C are also supplementary, that A and C have to be the same. That's a useful tool, and I think you should be able to see how this could be a useful tool, that if we're able to prove that one angle, in this case up here at the top, angle B, is complementary to two different angles, then those two angles must be congruent. Same thing here. We have angle B. If that angle is supplementary to two other angles, then those two angles must also be congruent. So there are two theorems from this section. We're going to jump ahead and go back through some other theorems. The right angle congruence theorem. This one should make a lot of sense to you. All right angles are congruent. So if this is a right angle and this is a right angle, they must be congruent. There's no way around it. I think that is easy to see. Interesting that it is a theorem, which means that it must have been proven at some point. It's not just a postulate. It's not just a rule we can accept as true, but that all right angles are congruent must be proved. How would you prove that? If you had to stop and prove that all right angles were congruent, how would you prove that? Well, I think you could see that if I had two separate angles that were both right angles, it would be a pretty simple, maybe a 2 or 3 line proof to show that both of those angles had a measure of 90. And since those angles had a measure of 90, then they had the same measure and that they were congruent. That's how you would go about proving it. Postulate 12. Now this is a postulate. Remember what that means. It is a rule that just can be accepted, doesn't need to be proven. If two angles form a linear pair, then they are supplementary. That's kind of something that we already know. It's the definition of what a linear pair is. Two adjacent angles that add up to 180. All we're doing here is we're just adding this word supplementary to it. A linear pair is two adjacent angles that are supplementary. That's the linear pair postulate, postulate number 12. And then theorem 2.6. This is also a rule that we have already been using, but now we have the official rule for it. Vertical angles are congruent. So that means that here's one set of vertical angles. Those two angles are congruent. Here's another set. I'll use a different color. These two angles are also congruent because they are vertical angles. That's the vertical angles theorem, and we can remember that rule by just saying VARC. Vertical angles are congruent. V-A-R instead of R, but V-A-R-C. Vertical angles are congruent. VARC. That is a rule we will use all year long. So there you have it. That's the entire lesson. In a second, I'm going to create a new slide. I'm going to write down what your homework is, but that is all that you need to know for today. I hope that you took good notes and you're able to do the lesson. I don't think the lesson will be too difficult for you, but as always, you can always email me. Email me if you have any questions. Okay, so here's what I want you to do for your homework. Here's your homework sheet. You'll see that you have some problems on page 113 due on Friday. What I want you to do is I want you to take page 113. I want you to pick any 5 of these problems listed here. 10, 12 through 22, 27 to 28. I want you to pick any 5 of them, and that's going to be your homework that is due on Wednesday, which is tomorrow. I will check this. It's only 5 problems. You can pick any 5 and do them, and as long as you show me that you did 5 problems from that page, that will suffice. But I want you to do any 5 problems from this homework. That will be your homework for tonight. Email me if you have any questions. I hope that this worked well for you. I hate that I can't be there today, and I look forward to seeing you all tomorrow. Toodles.